Section 8.4, the first part, is simplifying rational expressions. And if you'll remember, a rational expression is simply a fraction, and simplify means to get all of the factors that are in common out of there. So, step 1 is going to be to factor both the numerator and the denominator, and then step 2, reduce any common factors. And then you're done. Easy. It's going to be an easy day. Here we go. I want to show you on just a regular fraction. Reducing fractions, remember this is 15 is 3 times 5 and 65 is 13 times 5, right? 50, 60, yes. And so then the 5s are in common, so those can cancel, leaving you just with 3/13. That's all coming back to you now. Yay. Okay, easy sneezy. And this one is already factored out. 4 times the quantity x plus 3 all over the quantity x minus 5 times the quantity of x plus 3. The reason I did this was to show you that when you have these factors, make sure that you remember you have to factor out an entire factor. And sometimes a binomial is a factor. So this whole x plus 3 cancels out, the whole thing. So that leaves us with 4 over x minus 5. Now, you can't just cancel, oh look, I've got an x squared, I can cancel these. You can't do that. You've got to factor first, because this x squared is not a factor of this polynomial. All right, this is only a term within this polynomial. So first you need to factor, and then you can reduce any common factors. So with this, we're going to factor binomials just like you know how to do already. So x squared is x and x. The signs are the same and the signs are negative. 16 is, oh, guess what? We've got a perfect square. 4 times 4 is 16, and 4 plus 4 is 8. There we go. This one is x times x. And if you can do this quicker than me, go ahead and do it and then just check yourself. The signs are different, and the larger one is going to be positive. So we need a difference of 2. So we have, what, 6 and 4? Oh, that's it. 6 and 4, the difference is 2. We could have tried 8 and 3 or 2 and 12. But 6 and 4, the difference between them is 2. So a positive 6, because that's the bigger one. Negative 4. Check them just to be sure. Negative 4 plus 6 is a positive 2. That's what we need. Now we have the factors. So now it looks like this type of problem. And simply reduce by the entire binomial. So this binomial matches this binomial, so we can reduce, we can cancel out those two binomials. What we're doing is we're dividing by the same number on the top and the bottom, so we're just dividing by 1 is what's really happening there. So then this is our final answer, x minus 4 over x plus 6. Ta-da! Done. This is an easy, easy, easy day. Here we go. 40x plus 20 and 10x plus 30. You need to factor out a common factor. If you look and you can say, oh, let's see, 20 is in common between 20 and 40, but there's no x's. So take out a 20, and what's left is 2x plus 1. And then you can take out 10 here, and we've got x plus 3 in the denominator. I like it when they match. This one doesn't match, but that's okay, because we can reduce the 20 and the 10 by 10. So 20 is 10 times 2. So we just have 2 left, and then you can leave it 2 times the quantity 2x plus 1 all over x plus 3. You can either leave it like that, or if you wish to multiply the 2 through, that's fine as well. But for now, you can just leave it 2 times the quantity 2x plus 1 all over x plus 3. So with simplifying rational expressions, the biggest deal is just to make sure you remember to factor. Don't try to reduce based on what's in these binomials or trinomials. Make sure you're factoring first and reducing by an entire factor. All right, of course, I'm not finished, but I am close. I do have one word problem, and I didn't write the whole thing out, so kind of listen in here. Efficiency, companies try to make sure that their products are efficient, and efficiency is just how well something is used. And one way to measure efficiency in a product is, or in packaging of a product, is the ratio of its surface area to its volume. All right, so if you take the ratio of the surface area to the volume, the smaller the ratio is, the more efficient that packaging is. And so that plays into price of a product. So what we've got is a company is selling kitchen canisters and they have the same size base. The first size of cylinder is a cylinder, so it's a round base with the height equal to the radius of the cylinder. The second cylinder is also a cylinder. The second canister is also a cylinder with the height equal to twice the radius, so 2 times the radius. So what we need to do is we need to find the surface area and we need to find the volume of both of these cylinders, and then we can compare their ratios of their surface area to their volume. All right, so now, and what I want to pause just a minute. There's going to be some problems in your homework that involve geometric equations, so you'll need to remember what those are. They're probably in your book, and I didn't look to see where they are. But if you're not sure where what those are, you need to look those up. You can probably even look them up on the web, for pity's sake. Okay, here we go. So we need surface area. Surface area of a cylinder, if you'll remember, is the area of its base. 2 of the area of its base. So 2 of the areas of a base. A circle is the base because it's a cylinder, and the area of a circle is pi r squared. Pi r squared. So the area of a circle is pi r squared, and we have the top and we have the bottom. All right. Plus we've got the edges, and so if you remember, if you take the label off of a can, then it becomes a rectangle. So we're going to take that rectangle, and it's going to be the circumference of the circle, and the circumference is 2 pi r. And then you're going to multiply it by the height. So times the height of the canister, of the wrapper. All right, so this is the 2 ends, this is the 2 circles, and this is the rectangular wrapper, for lack of a better term. And now if you'll remember, we have a comparison here. In the first cylinder, the height equals the radius. So what we can do is we can replace this height with radius, and so now we have 2 pi r squared. So we've got, this is the bases, and this is the lateral side. All right, so now we've got 2 pi r squared plus 2 pi r squared. So together, your surface area is 4 pi r squared. So this is number 1, the surface area. All right, so far so good? All right, so now to find the volume of this same cylinder, remember the volume is the area of the base times the height. And we said the area of the base is pi r squared, so pi r squared times the height. And if you'll remember, the height is the same as the radius, so let's just put in another radius. And so the volume of number 1 is pi r cubed. All right, so there's number 1, here's the surface area, and here's the volume. Now we need the second. So now we need to do the same thing, the surface area and the volume of the second cylinder. So let's take, we've got 2 bases, and they're actually going to be the same. So we've got 2 pi r squared for the bases, and then the lateral area of this is going to be 2 pi r, remember, is the circumference, and now we're going to multiply by the height. And this height, the height of the second cylinder, is 2r. So we're going to multiply by 2r. So now this lateral height is 2 times 2 is 4 pi r squared. So we've got 2 pi r squared for the top and bottom, and 4 pi r squared for the wrapper. And so together, the surface area is going to be 4 plus 2. 4 plus 2 is 6. 6 pi r squared. So there's our surface area of number 2. And the volume, oops, I didn't put surface area here. So the volume now is going to be pi r squared times the height, and we said this height is 2r times 2r. So now when we multiply that across, this volume is going to be 2 times pi times r cubed. All right, so now what we need to do is we need to set up these ratios. And this is where it comes back to what we're working on today. We're going to need to reduce this ratio to compare them. So we've got 4 pi r squared over pi r cubed. So for the first one, number 1 is, its ratio is 4 pi r squared over pi r cubed. And my second one is 6 pi r squared over 2 pi r cubed. So now I've got my two ratios. All I need to do is reduce them. So the pi's are the same. I've got 2 r's here and 3, so I can take 2 out of this one and have 1 left in the bottom. So this ratio is 4 over r. And this one, let's see, the 6 and the 2, 6 is 2 times 3, so the 2's will cancel, my pi's will cancel. I have 2 r's on top and 3 on bottom. So this, once I reduce, I have 3 on top and an r on bottom. So now I'm comparing 4 over r and 3 over r. And remember, so this is the ratio of the first canister, its surface area to its volume. This is the ratio of the surface area to the volume of the second canister. We're trying to determine which canister is the most efficient, and whichever one has the smaller ratio is more efficient. Now if we look, because the denominators are the same, we can simply say, well, because the denominators are the same, I know that 4 is larger than 3, so 4 divided by r is going to be larger than 3 divided by r. So the smaller, this is where it gets confusing, the smaller the ratio, the more efficient. So canister number 2 is more efficient. And actually, we probably could have figured that out just with logic, right? Because if you've got less packaging for more stuff that you're filling it with, it makes sense, right? That the larger package would be more efficient because it's going to hold more with less packaging. So the second canister, the larger cylinder, is actually going to be more efficient. So that's all I have for you today. Reduce some fractions, simplify rational expressions, and some word problems with geometry. See you next time.